Now, we would like to work on the last couple example of the section 4.5 to finish up this package now, okay? And again, I hope that you could use the idea or technique that I introduced from the last videos, okay, to work on this the following problems now, okay? Okay, so to this number 5, I would like to sketch the functions of a function that satisfies all the given conditions. Okay. So then let's see how do we actually, again, gathering all the information that we have. Okay. So to this one, I have f prime of x greater than 0 for all x not equal to 1. And vertical asymptotes is x equal to 1. Okay. So then maybe let us try to work with f prime here. And now I write down 1 here, okay, is from the left and the right of 1 is all positive. And then notice that x equal to 1, we have a vertical asymptotes at x equal to 1 then. Okay. Then now, from these informations, we actually, right away, we know that if I translate to the f functions, and again, they will indicate that this is a vertical asymptotes, meaning I actually have it increasing to the left of 1 and also increasing to the right of 1. Okay. And now, let us look at other informations now. Absolute prime of x is greater than 0 if x is less than 1 or x is greater than 3. So now, I actually have information about absolute prime. Okay, so 1 and 3. Okay, so again, remember we have a vertical asymptote at x equal to 1. Then now we have a positive when x is less than 1 or x is greater than 3. Now absolute prime of x is negative. Okay. If x is between x equal greater than 1 and x is less than 3, right? Okay. Then again, let us translate this one to the f functions again. So I have 1 and 3. If that in mind, x equal to 1 is a vertical asymptotes, then now, so this one, positive of absolute prime is concave up, okay, of f. Then negative is a concave down. Okay, so and now let's see, okay, how do we actually sketch the function now? Okay, so we have a 0 and then 1, 2, 3. Okay, so then to this one, maybe let us indicate the vertical asymptotes at x equal to 1 first, okay? Okay. Now remember, how is the function behave nearby the vertical asymptotes? Is the function either go to infinity or go down to negative infinity, right? Something like this. Okay, then let's see how we actually, again, work it out, the problem that we have here. Okay. Then let us work with f prime. Remember, to the left of x equal to 1 is positive, meaning the function is increasing. Okay, so the function is increasing here, and also the function is increasing here. Okay. Okay. And now, I actually have more informations that, oh, let's see. To this one, we have, okay, inflection point at x equal to 3. So at x equal to 3, I have inflection point. Okay. Then let's see how we work it out to finish the graph now. Okay. So in this case, then for x, again, to the left of x equal to 1, the function is concave up. So, and then remember, we need to have, again, when x approach the vertical asymptotes, x equal to 1 is go to infinity. So then in this case, maybe we could have, okay, we could do it this way, okay. And then now between 1 and 3 is actually is a concave down, but the function is increasing. So now we have concave down, okay, and then concave. Okay. So, so probably this is actually is a possible function f then. And now let us look at the next example, number 6. Okay, so to number 6, the graph of a function f is shown. So we have the function f here. And then which graph is an antiderivative of f and y? Ooh, what does this mean by antiderivative? Okay, now notice that an antiderivative of f is a function f such that f prime is equal to f. Okay, well, it seems that is not really easy to understand, huh? Okay, now basically, we actually that's mean from the beginning of the class, we started from f, and then we go through the derivative, and then we find f prime, right? This process right here is the derivative that we have. Okay, and then the antiderivative is mean that now we have f prime, and then I would like to find the original function f. Okay, so this is the idea about the antiderivative. Okay, so what does this mean here? Okay, so it's mean that right now, okay, so for example, f of x equal to x squared, and then I have f prime of x is equal to 2x. Meaning right now, I have the graph of 2x. I would like to find the x squared. That's mean my function f. Okay, so this is kind of like the idea then. So a little bit easier to understand is right now, this f function is the derivative of some function capital F. Okay, then now I would like to find the function f. Okay, so then in this case, basically, you should ask yourself that is the function a is the capital F, or b is the capital F, or c is the capital F. Okay, which is the antiderivative of this f function right here. Okay. Okay, so then let's see. Now we actually I have some label here. Okay, so x of 1, x of 2, and x of 3 to actually to help us to actually to again work it out the problems. Okay. Okay. Then what information do I know? First, I know that f prime that's mean f of x of 2 is equal to 0. Okay. In other words, meaning I have a capital F of x of 2 equal to 0. Okay, so meaning x of 2 basically is the good numbers of f then, right? And then if this is the good numbers here, then you will see that to this f function here, these portions between 0 and x sub 2 is below the x-axis, meaning this is a negative here. Okay. And on the other hand, from x sub 2 to infinity, right, is a positive. Okay. So, or about the x-axis. So this is a positive right here. Then if I want to translate to the f functions, that means this one is decreasing. To increasing. Okay. Then from decreasing to increasing, we have a local minimum at x sub 2. Okay. Then in this case, the only function that I have the local minimum at x sub 2 is the function b, isn't it? So that's why my answer in this case, it will be b then. And now the next problem is the figure shows that we have three functions a, b, and c, and then they all represent the f function, f prime, and f double prime. I would like to identify each curve and explain my choices then, okay? Okay, so then in this case, basically what I would like to do is I would like to match the f prime and f double prime to a, b, and c, okay? Then maybe let us start, right? We always want to start something, okay? Now, think about this. If I start with the curve C, okay? If C is the f functions, that means in this case, okay? Then for f prime, that means in this case right here, we will have a 0, okay? It seems that maybe A will be, actually it's not, because again, one thing about this is increasing, then this is, we will have the local, that means we will have a critical number as x sub 1, okay? In this case, it seems that. But one thing about this is, if this is increasing, that means the functions must be about the x-axis. So then, that means if C is F, then we have nowhere to go. Then let's try B then. Okay. Then to B, we have a local maximum at x sub 2. Okay. And then to this one, it is increasing, meaning the functions must be about, that means the derivative, right, must be about the x-axis. So then it seems that, okay, if B is F, then C is F prime. But we know that we don't have the derivative of C, so that means B is not the F functions. And now let us look at A now. If A is F, then now the good number that I have is somewhere here. Okay, so maybe this one x of 4 is my good numbers. Okay, then mean the function is increasing and then decreasing. So then you will see that what happened to the function b, we have a positive and then negative. Oh, then if a is f, then b must be f prime. Okay, and then if b is f prime, then of course c, we just found out that c is the derivative of b, right? So then c must be f double prime. So therefore, this should be the match that we have then. Okay. Okay. And now let us work on the last problem now. Okay. Now to this problem, I would like to find the interval of increasing or decreasing. So when I see this, meaning what we are looking for, the f prime, right? We want to work with the f prime. And we would like to find the local maximum and minimum. Again, is related to f prime again. For C, I would like to find the interval of the concavity. Okay, so when I see concavity, meaning now I need to work with the f double prime. Okay, and then use the information from part A and B, and then we would like to sketch the functions. Okay, so therefore, again, when I try to work it out this problem right here, what I would like to do is I would like to find the B prime and B double prime. Okay, this is okay. Okay. And now let's see. For B prime, then we will have 3 times the derivative of x to the power of 2/3 and minus the derivative of x. Okay. And now the derivative of x is 1. Okay, so then now we have 3 and 3 cancel. So in this case, I have 2 times x to the negative 1/3, then minus 1. Okay. Maybe we could rewrite this into 2 over cube root of x minus 1. Or we could rewrite this into the form that is 2 minus cube root of x over cube root of x. Okay, now this is actually easier for me to find the good numbers then. Okay. And then now we try to find the b double prime, the second derivative. So which is the derivative of b prime, right? Which is the derivative of 2 times x to the negative 1/3 minus 1. Then opposed to this one, so we will have 2 times negative 1/3 x to the negative 4/3, and then minus 0. And maybe let us try to see if we could simplify this. Okay. So I will have negative 2 over 3 times cube root of x to the power 4. Okay. Or if we want to simplify more, then we will have this one will be cube root of x to the power 3 times cube root of x. Okay, something like this. Okay, so now after we find b prime and b double prime, then now we would like to again work with the psi chart, right? To find out to find the interval where the function is increasing, decreasing, and determine the local maximum and minimum now. Okay. Then now, to A, I would like to create the psi chart. For f prime, that means I would like to find the critical numbers. Then I would like to set b prime of x equal to 0, or b prime of x does not exist, right? Okay. And I have 2 minus cube root of x is equal to divided by cube root of x equal to 0. And basically, if we multiply both sides by cube root of x, we only have 2 minus cube root of x equal to 0. Okay. Then we could raise both sides by the power of 3. Okay. Then I have x is equal to 8. And what number will make the b prime does not exceed? It will be the 0 in the denominator. So x is equal to 0. Oh, then now we have, again, this one will be b prime, okay? 0 and 8. Those are the critical numbers for b prime, okay? And then now what I need to do is I would like to choose a number, for example, the -1, 1, and maybe 27. Okay. Again, the reason is 27 because we need to work with the cube root, right? Okay. Then we work with the b prime. Okay. And now, if we plug it in -1 for x, then basically we will have 2 minus cube root of -1 over cube root of -1. Okay. So in this case, we will have 2 plus 1 over -1. So then this is a negative right here. And we have 2 minus cube root of 1 over cube root of 1. So I have 2 minus 1 is positive, and then cube root of 1 is 1, right? So then in this case, I have this is positive. And then now I have 2 minus cube root of 27 over cube root of 27. Then we have 2 minus 3 over 3. So we have a negative right here. Okay? And now we would like to change it from the b prime to b. So we have 0 and 8. Okay. Then negative of b prime is decreasing. Positive of b prime is increasing. Okay. And now we will have from decreasing to increasing is a minimum. Increasing to decreasing is a maximum. Okay. Then now to A, we could say that is decreasing. Oh, by the way, let's see. I should do it at the beginning, but again, let's try to see the domain. Okay. Let's find the domain of the function b first. Okay. Okay. Then you will see that to the domain of the function b, we have 3 times x to the power of 2/3, and then we know that x to the power of 2/3, okay, or 3 times cube root of x squared. Okay. Basically, remember the cube root, the domain is all real numbers. Okay. then x again is all real numbers. So the domain of the function b basically is negative infinity to infinity. Okay. Then now I will be able to work with the interval now. So decreasing is from negative infinity to 0. Okay. Union with 8 to infinity. Okay. And then increasing is between 0 and 8. Okay, then now let's try to work with B. B, I would like to find the local max and minimum values. Okay. Now remember, when they are going to work with the values, meaning we are looking for the output, right? The y values. Okay. So meaning to this one, we need to work with the B of x. Okay. So we know that the local minimum is at x equal to 0. So we could say that here, when x equal to 0, b of 0 is 3 times 0 to the 2/3 minus 0, which is 0. Okay. So then, local minimum is at 0, 0. So the minimum values is 0. Okay. Then now, when x is equal to 8, we have a local maximum. Okay. So I have b of 8 is 3 times 8 raised to the power of 2/3 minus 8. So 8 is 2 to the power 3. Okay, so 3 and 3 cancel, meaning we have 3 times 4 minus 8. So then in this case, I have 12 minus 8, so which is 4. And now I have my local maximum point, okay, at 8, 4. Okay. Then in this case, my maximum values is equal to 4. And now, to see, I would like to find the concavity and the inflection point. So in this case, I would like to set the b double prime of x equal to 0, or b double prime of x does not exist. Okay. Then we have b double prime of x is equal to negative 2 over 3x cube root of x. Okay. That means the only number that make the b double prime undefined is when x equal to 0. Okay. Then now let us work with the b double prime now. So again, we have this 0. And right now I would like to work with the 2 test point. Maybe let us work with -1 and 1, right? I have the b double prime of x is -2 over, maybe let us work with 3 times cube root of x to the power 4, okay? Then, in this case right here, b double prime of -1 is -2 over 3 times cube root of -1 to the 4. So basically, this is a negative number, okay? Because this is actually -2 over 3 times cube root of 1, right? So, and b double prime of 1 same thing, is also a negative. Okay. Okay, so if this is the case, then let us translate this to the b, meaning I will have the concave tan and then the concave tan. Right? Okay. And now to this one, we could answer this is the concave tan that we have is from -infinity to 0, then union 0 to infinity. And then we have no concave up, then of course we do not have inflection point, right? Then now the last part is we would like to sketch the function now, okay? Okay, so in this case, we only have this 0 and then 8. Okay. And then now we find out that we have the local minimum at x equal to 0, and the point is 0, 0. Okay. And then we have a local maximum at the point h4, okay? And then now, basically, the function is, again, is decreasing, increasing, and decreasing, okay? And now we only have this is concave tan, okay? So that means basically the function is concave tan and then concave tan again. So then this actually is my function b then. Okay. Okay, so thank you.